already been talking about arcs of a circle. Now we're going to go into how they name them. So, an arc of a circle is 2 points on the circle, and the continuous part of the circle that's between those 2 points. It is not a straight line. It is a curved area. The 2 points are called endpoints of a circle. I would think they're called endpoints of an arc. Just like a segment has endpoints, an arc is going to have endpoints. This is 10 From here, we're going to go into 12.1 and we'll be in the book for the rest of the semester. You all did great. I'm just making it. I think I did very well on the ready to piece. You guys have That's a fascinating. Alright, a semicircle is special. It's an arc of a circle whose endpoints are the endpoints of a diameter. And you can kind of get some people today. You do already know this, but you already worked it. That's center C. The interesting thing is, after this test, we're going to be working solely in degrees. So, we can make that switch, because everything we do from here on out is going in degrees. How many degrees are there in the circle? 180. You all already know that. Do you also know what radian measure that would be? How many degrees of radian measure? I put 2 up here. Alright. A minor arc is an arc of a circle that's smaller than a semicircle. Smaller than a semicircle. Its measure, therefore, is less than 1 degree. Measure less than 1 degree. Semicircles measure is. If you have that spreadsheet, it would probably be good thing to have out. That spreadsheet of geometry terms. You've got that, pull that out and you'll add to it. Now, if we have a minor arc that's less than 180, it's named with its index, with an arc symbol above. So this would be arc AB. If I put a C over here, we would have arc AC. I could even talk about arc CB because that's less than 180. And arc AC is the same thing as arc CA, just like you with the 7. Arc BC is the same arc as CB. I'm going to erase the C thing. This is the issue that came up. If we talk about arc AB, were we talking about the yellow arc? Or we were talking about this really large all the way from here to here. That was an issue. So in order to make that differentiation, I'll show you what we're going to do. A major arc is an arc of a circle that is larger than a semicircle, which means a major arc has a measure that is greater than semicircles. And major arcs are named with 3 letters, not 2. That's how we get them. So if I use letters A, B, B, then the end letters, meaning A and B, are going to be the end points of the arc. The middle letter is a point that the arc will pass through. So you know if you see 3 letters, it's either going to be a semicircle or it's going to be a major arc. So if I remember, I wrote A, D, B. That way you know it's the blue arc, not the yellow arc. So today you're just going to be playing with all sorts of circles. So here's an example. A, M, Y is greater than 180. So one of the things you need to do is be able to recognize a major arc from a minor arc from a semicircle. And at the end of this lesson, you all can tell me whether or not, well, I don't know if I can do this in this test or not. Congruent arcs are arcs with equal measure. Looks like you do segments and segments to begin with. You do it in the picture. You're going to be playing with arcs. Now, if you have to add, subtract, multiply, divide on this homework, I want to see where. If you give me a whole list of just angle measures, I'm not going to be paid. And I'll show my work, model what I mean. Okay, so minor arcs. Let's name some minor arcs. You ready? Okay, are you going to record? Okay, step into your paper so I can see. Alright, I need a minor arc. Hope you name a minor arc in my circle. There's lots of AD would be a minor arc because it is less than 180. Less than, smaller than a semicircle. I need another minor arc. Parent? A2. Where's my 2? Yes, that is definitely a minor arc. Okay, let's do another minor arc. Okay. AE is another minor arc. Eric? Okay, CF, F to the center. So an arc has to be along the edge of the circle. CE would work, because that is definitely less than a diameter. All right, one more, and then we'll go to semicircles. Okay? Yeah. Easy? All right, and that's not, I mean, there's more. Now, on this next one, there are exactly two. Devin, what's one? You have to make sure that it's going to go through that. So when a diameter must go through the center, and for the most part, you can't assume it goes through the center unless you literally see it go through the center. So, pardon? Okay, AF is is it along the circle, or is it a radius? The radius, so I need a semicircle. I'm going to point it in. We'll make that there. Does that help? Okay. All right, now, how many letters do we need for semicircle? A what? Okay. There you go. ABW. ABW is the upper semicircle. He could have said AGW. He could have said ACW. So now I want a different semicircle. What was the middle letter? D. Okay, AEW. He could have said AEW also. Those are semicircles, those are exactly 180. Now I need arcs that are bigger than 180. Oh. CE, don't stop there. That's not bigger. CE what? CEG is definitely a major arc. Over 180. Alright, and on these we got lots of these. Tommy? CBD. Alright, that means we start at C, we pass through D, we go all the way up over here. That is a major arc. Alright, let's do one more. Another, so part of your homework is naming these sort of things. Karen? We've got B, C, A. So she starts at B, she passes through C, and goes all the way around to A. That is a major arc. So, was there any work to be shown on naming these arcs? No. Alright. So now we're going to talk about a central angle. This is our first angle I'm introducing you to. We're going to have lots of them before we're finished. Central angle is an angle. Key piece. Vertex is on the center. The vertex will change as we go through this unit. And the sides pass through the influence of the arc. So in degrees, the measure of a minor arc is equal to the measure of its central angle. So if I want to look at this arc right here, I think that's a half. Okay. So a minor arc would be angle BFC. That would be a central angle, and it cuts off arc BC. So if I told you this was 40 degrees, then we know that this is 40 degrees. The vertex must be on the center. So it says the measure of GFA, the angle is 28 degrees. GFA. If this angle is 28, then what is this arc? 28 degrees. So this is in degrees. This is not true about radians. Radian measures based on the radius, not on degrees. So AG is 28. Did I need any add, subtract, multipliers across? Alright. So if AED, no, it's the measure of angle AED, this whole angle, right? If the measure of this whole angle is 9x minus 13, and the measure of arc AD from here all the way over to here is 7x plus 21. What equation do you think we're going to write, Travis? Excellent. Because the measure of a minor arc is equal to the measure of its central angle. So we're back into the algebra. So we're going to subtract 7x. So you're going to have 2x minus 13 is equal to 21. We're going to add 13. So that's 34. We're going to divide by 2 and get 17. Without anything else. So can you bring back our algebra? All right, angle AEH. That should be F. Angle AEF. This angle is 5x minus 13. That means from here to here is 5x minus 13. My question to you is, what would its equation be? Yep. Exactly, because that is this AFH, the diameter. So we would add 13, we would have 5x equals 193. So x would be 193 over 5. All right, this is the same picture. Okay. So now they're telling us that arc HT, this arc is 7x plus 12, and they're telling us BFH. EFH is 9x minus 14. What do we have, Jenna? For this equation? Measure of a central angle, which is what we have, is equal to the measure of the arc. So we're going to subtract 7x. We're going to add 14. So we're going to get 26 is equal to 2x, so x is equal to 2. Yeah, whatever. I think you only have one problem on this one with the algebra. You know how that is. So I'm going to look at my next slide, and not what I think it is, and we're going to play with this picture for that. Any questions? Yeah, central angle and the arc. The central angle is equal to the measure of arc 30 degrees. Yes. I don't think so. I think I'm putting that in this. All right, now, arc addition is like segment addition. The measure of an arc formed by two adjacent next to each other arcs is the sum of the measure of the two arcs. Notice the little measure like the English. Measure of W. Measure of W. Measure of W. Yeah. If this arc is 32 and this arc is 59, we want to know the measure of the arc from here all the way over to there. What did you have to do to get to that? Do I have to see that addition? Yes. 32 plus 59 is equal to 1. Now, instead of this, I could have said, what's the measured angle WDT? Why could I have done that? Because the measure of the central angle is the same as that arc. Just that arc. So, WT Let me erase this. Alright, so now I've got WT is 89. That means from here all the way over there is 89. And I'm telling you TE is 44 degrees. Now I want to know the measure of WDE, that angle. What are you going to do to get that angle? This is more like what you're going to say.
89 minus 44.
Okay, so the measure of my angle WDE is going to be, you said 89 minus 44. Did you have to show that work?
Yeah.
And I think that's 55. Is that right? No, it's 45. What do you think? Do you like this? Because this time I'm doing the whole on that part of it. So what I could have done is I could have let that be x. So arc x plus arc 44 gives me 80. Okay, and then I subtract 44 and I get 35. Here I was given the two numbers, so I would have said 32 plus 59 in this case would have been x. Does that make sense? Okay. So let's see if I have anything else. So center, we've got AC and EB are diameters. BC equals 63. What is BFC? Class? Unison? What's the angle? 63. If AE is 37 and DC is 53, can you find that arc knowing that is their diameter? And the work you would show me is 180 minus 37 minus 53, correct? Okay, so this is the more of the flavor of your homework. Almost all numbers. So I need you, if we have major arc EBC, and I want you to find EC, what if I tell you the arc all the way over here is 148 degrees? So how do you find this arc from E to C? And then, if I tell you this big green arc is 148, how do you find that arc? Say 360 minus 148. Alright. Right. Yes? Oh, hold on. Okay, did you mark that so I'll know?